Namaste. Once again, welcome back to the online maths class. Till now, we have learned some aspects of different classes of functions like polynomial functions, rational functions, and trigonometric functions. In this section, we shall learn a new class of functions called exponential functions. What is an exponential function? Let's see. The functions of the type y is equal to f of x is equal to b raised to x, where b is greater than 0 and b not equal to 1 is called an exponential function. Once again, the functions of the type y is equal to f of x is equal to b raised to the power x, where the condition is b greater than 0 and b is not equal to 1. Why there is a condition like that? Let's look at the first one, b greater than 0. So if b is less than 0, then what happens? Look at this example. Let b is equal to minus 2 and x is equal to 1 by 2. Now y becomes y is equal to minus 2 raised to 1 by 2. That means root of minus 2. And obviously it's not a real number. And the second one is b not equal to 1. If b is equal to 1, then y is equal to 1 raised to x. 1 raised to x. X can be any real number. If x is 1, y is 1. X is 2, y is 1. If x is equal to 100, y is equal to 1. That means the image is a fixed number. That means the function is a constant function. So this violates the nature of exponential function. Exponential means a rapid growth. It shows a rapid growth. It's an ever increasing function. As x increases, y also increases. The function also increases. So it's not possible. That is why it's given that b not equal to 1. So once again, exponential functions. The functions of the form y is equal to f of x is equal to b raised to x, where the base b greater than 0 and b not equal to 1 is called an exponential function. Clear? Now we can talk about the domain and range of this exponential function. So first one is domain. So domain means the values we can given instead of x. That is what is called the domain. So here we can give any real values. If it is positive, negative or 0 instead of x. There is no problem, no restriction in it. So the domain is the set of all real numbers. Domain is equal to the set of all real numbers, that is R, or we can write it in interval form as open interval minus infinity comma infinity. That means the set of all real numbers. The second one is range. If we replace x by any real number, we get a corresponding y value. That collection is called what? Range. So there are three possibilities for x. That is, x is less than 0, x is equal to 0 and x is greater than 0. So let's take it. First one, x is less than 0. That means negative real numbers. Okay, negative real numbers. Let's take an example. X is equal to some minus 5. Okay, what happened? Y is equal to b raised to minus 5. And we can rewrite as 1 by b raised to 5. And here b is greater than 0. B greater than 0 means this number is positive. Okay. So the whole term is what? Positive. Okay. So if x is negative, then in that case also we get a positive value as the image. Then next one is x is equal to 0. So when x is equal to 0, we get y is equal to b raised to 0. And we know any number power 0 is what? 1. So it's also positive. And the third one is x is greater than 0. That means set of all positive real numbers. Here also we can take one example. When x is equal to 2, y is equal to what? B raised to 2. B is positive, so b square is also positive. So in this situation also we get a positive value. So the range is always the set of all positive real numbers. So range we can written as positive real numbers, that is R plus, or we can written in interval form, open interval 0 comma infinity, open interval 0 to infinity. So once again, domain is the set of all real numbers and range is the set of all positive real numbers. Okay. Now there are two particular types of exponential functions. One is y is equal to f of x is equal to 10 raised to x. Here the base is 10. This is called a common exponential function. Common exponential functions. Okay. Then the second one is y is equal to f of x is equal to e raised to x. Here the base is e. It is called a natural exponential functions. So an exponential function with a base 10 is called a common exponential function, and an exponential function with a base e is called a natural exponential functions. Okay. Here the letter e is called a Euler's number. Euler's number, and the value of e lies between 2 and 3. That is 2 less than e less than 3. And the approximate value of e is 2.71818281 and so on. So while observing the decimal expansion of this number, the decimal expansion is non-terminating and non-repeating, and hence it is an irrational number. E is an irrational number like pi. Okay. And one additional thing you have to remember is there is an infinite series expansion for e raised to x. That is e raised to x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. up to infinity. And hence e can be written as e is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus etc. up to infinity. Okay. Now we shall discuss the graph of exponential functions. Let's take some examples. Y is equal to 2 raised to x, y is equal to 3 raised to x, and one more y is equal to 10 raised to x. So these are some examples of exponential functions, and we are going to draw the graph of these functions. Okay. So first we can draw x-axis and y-axis. Here the horizontal axis is called what? X-axis, and vertical axis is called y-axis, and which is origin. First we can draw the graph of y is equal to 2 raised to x. Now I am going to draw a rough sketch of it. Listen. So this is y is equal to 2 raised to x. and y is equal to 3 raised to x y is equal to some 10 raised to x. So we can observe from the graph that this function, that means the exponential function, is an increasing function, ever increasing function. The x value increases, the y value also increases. So it's an ever increasing function. And the second one is 0, 1 is a point on the curve. That means the point on the graph, or otherwise we can say that the graph of an exponential function cut the y-axis at the point 0, 1. So 0, 1 lies on the graph of an exponential function. And the third one is, if we extend the graph in the second quadrant, that means if I extend this one, the curve approaches to x-axis but doesn't touch it. Here also, if we extend, it looks like this. It doesn't touch the x-axis. So the graph never touches the x-axis. Hope you understood the concept. Thank you.